Hello children. Lesson number first, geometric construction. Under this lesson, in first lecture, I taught you how to draw the angle bisector and how to draw a perpendicular bisector. In second lecture, I taught you the property of the angle bisector of a triangle, and inside it you have to draw the triangle. I told you draw the triangle and draw the which angle bisectors for that triangles, okay, and then you will get the point where all these angle bisectors are passing from the single point, and that point is called as a concurrent. These lines are concurrent lines, and that point is called as a point of concurrence. And inside it, IA means perpendicular distance between the point of concurrence of angle bisectors and these sides of a triangle are equal, means IA is equal to IB is equal to IC, that we had seen. Okay, next property is the property of perpendicular bisector of the triangle. The property of a perpendicular bisector of a triangle, and that we are going to see now. And for that, this property we are going to check with the for acute angle triangle, and second for obtuse angle triangle. Okay, for obtuse angle triangle. For that, here some steps are given that I will show. Read it first. Use a ruler to draw a acute angle triangle, means we have to draw any acute angle triangle, and we have to draw its perpendicular bisector. As angle bisectors are passing from a single point, same thing is happening with this. Okay, all the perpendicular bisectors of these triangles are passing from a point, that is the same point, that is a common point, which that is the C. For obtuse angle triangle also, what this all perpendicular bisectors, what happens, they're passing from a single point. For if you see here, you will notice that here it is the difference. For an acute angle triangle, okay, these all perpendicular bisectors meet inside the triangle. Here it is the border of triangle XYZ, okay, and you will notice that this the C point, means point of concurrence of these lines is inside the triangle. And that of for obtuse angle triangle, in this figure XYZ is a obtuse angle triangle, okay, and in this figure you will notice that the perpendicular bisector is there, it is outside the triangle. Okay, and afterwards we have to check what the distance between the CX, CY, CZ. Same thing, CX, CY, CZ. Is it equal or different? That we are going to see after doing the constructions of this. Okay, and for that, let us see how to draw the perpendicular bisectors for triangle XYZ. Okay, this is the property. The property of perpendicular bisectors of a triangle that we will see now. So, to draw this figure, we need a pencil, compass, a scale, okay, these things are necessary, and also the divider is necessary. In our compass, the like compass, one more in the divider is there, okay, that we are using, means both has a metal points, and that we are using to check the distance. Now I don't have, so I will use this only compass to check the distance between these two, CX, CY and CZ. Okay. Now, to draw the perpendicular bisector for a triangle, first we will see how to draw the perpendicular bisector for a acute angle triangle. Okay, and for that I will draw here one triangle which is acute angled triangle. Okay, so this is our triangle. I will name it X, Y, and this is Z. This is acute angle triangle. Now we have to draw the perpendicular bisectors. One thing you have to keep, angle bisectors means we have to do the draw the angles bisector, and perpendicular bisector is for the sides of a triangle. So for that, first of all, we have to adjust the point, metal point of a compass and the pencil's nose with equal distance. Okay, and now we will start to draw the perpendicular bisector. For that, this metal point is there, that we have to keep on one point of one vertex of a triangle and take any side to draw the bisector of this. For that, you have to take more than half distance, okay, which xy segments by perpendicular bisector we will draw now. We have to take more than half distance in our compass. Draw the arc above the line xz, okay, and another arc below the line xz, okay. Now without changing distance, we have to keep this metal point on x. Yes, see here. Then you just draw the arc which will intersect the first arc. If it doesn't intersect, don't worry about it. Again put, without changing distance, again put this metal point on this and just increase the length of the arc. Now you got it. The two intersecting means pair of intersecting arcs, and now you have to join these points, okay, and this is the perpendicular bisector for side xz, right? Now same procedure or same steps we have to follow and draw the bisector for xy. Draw the bisector for xy. So here again take the distance in your compass which is more than half of a xy whose perpendicular bisector we are drawing. Now draw the arc above the line and another arc below the line. Pick up this compass and put, without changing distance, we have to keep this metal point on x and we have to draw the arc which intersect the first arc of that we had drawn from the y. And now the same thing, join this, the intersection of these arcs, and draw the line which is passing from these intersections, right? If you see here, they are passing from this point. Now one side remain, that is first we draw the xz's, then we draw the xy's perpendicular bisector, then another side remain, that is the yz. For that, again you have to take the distance more than half of this yz in our compass, okay. If you see here, I took more than half distance. Same steps we have to follow. Draw arc from point x above the line and the below the line. From z point, draw the arc which intersect the first arc, okay, and now draw the perpendicular, draw the line passing from these 2 points. You will notice that this line is passing from the single point, okay, that only point. If you see here, the perpendicular bisector of xy, xz and yz, it is passing from the point C, and that point C is called as a circumcenter, okay. Now if you have a divider means the instrument, it is there in the compass, it has such a type of metal point, okay. Both side metal points are inside of pencil, the metal point is there. Now I don't have this, so I will check the distance of C and X by using this only, okay. No, only check the distance. If you see here, Cx is, how much is Cx, how much is Cy, and how much is Cz. You will notice that all the distances, if you see here, all the distances means xc equals to yc and equals to zc, means my construction is correct. If these three perpendicular bisectors, they are not passing from a single point, then your construction is wrong. So for that you have to take the compass which is tight, okay, pencil which has a proper nook, okay, and then your construction will be correct. This is the construction. This is the construction, okay, of acute angle triangle. Same constructions we have to do for the obtuse angle triangle, and for that I will draw one here obtuse angle triangle. Okay, if you see here, you will notice that one angle is more than 90. Okay, this is x, that is y, and this one is z. My z angle is more than 90 by observation also you can see here, and that's why it is a obtuse angle triangle. Okay, now I will put this metal. Same procedure we have to follow which we have used here for this acute angle triangle, for this obtuse angle triangle also. Now put this metal point on z. Take more than half distance in a compass. This CXZ is greater, so the distance more than half we have to take in a compass. Draw the arc above the line. Now put this metal point on X. Take the, without changing the distance here, and downside also we have to draw the arcs here. I forgot. Then the draw arc which is passing from or intersecting the first arc. Now I got this. Join these two intersecting. Okay. Now I drawn the XZ's perpendicular bisector. Now I will draw the XY's perpendicular bisector. Again same steps, more than half distance. Draw the arc this side and another side. Then put it on X. Draw the arc intersecting the first one. Okay. And just join these two arcs. Intersection of arcs. Okay. So here I got that point. Now one side is remain, that is YZ. I will draw the perpendicular bisector for this. Take more than half distance in a compass. Arcs which are passing from point Y also. Okay, and draw the arc. Okay, if you see here, you will notice that and this also intersection of these two arcs is passing from this single point, and that point C is there. Okay, if you check the distance from C to X, C to Y and C to Z is same. Here also XC is equal to YC is equal to ZC, and in both construction inside what happens, we get the distance of vertex of a triangles and the point of concurrence of the perpendicular line is same. Same for this acute obtuse angle triangle also. The distance between the point of concurrence of angle bisector of a triangle and the vertex of the triangle is same. Okay, and one more thing is that for acute angle triangle, this point of concurrence is the inside the circle, and for obtuse angle triangle, this point is outside the triangle. Okay, these steps you have to follow, and you have to do this both the construction. Okay, so this is the zoom. In zoom I will show you how I had done the construction and how it is there, and this is the another construction. Okay, this is the another construction, that is the obtuse angle triangles. This is the point of concurrence, and here it is the point of concurrence. For these perpendicular bisectors, this point of concurrence is called as a circumcenter. Here it is the circumcenter, and for obtuse angle triangle, that point is called as a incenter, that I will show you now. So now we done this both the construction, and I shown you how to draw this both the construction. Okay, and we measure Cx is equal to Cy is equal to Cz. Okay, for both the figures. Here yesterday I shown you the incenter. What they told you, the angle bisectors of a triangle, the angle bisectors of a triangle are concurrent, they are passing from a single point, that's why they are called as a concurrent, and their point of concurrence is called as a incenter. Means angle bisector I for in center, CENTRE. And this we are drawing for which figure? This first one that we have completed yesterday. For this, these are the angle bisector, and the angle bisector's point of concurrence is called as a in center. Okay. Then next, for perpendicular bisectors, if in these both figures inside, perpendicular bisector means sides. Okay, so perpendicular bisectors of the sides of a triangle are concurrent, and their point of concurrence is called as a circumcenter. Okay, this is the circumcenter and shown by the letter small capital C. Okay, so today we stop here only, and these are the construction, that two constructions practice you have to do in your home. Okay, so today we will stop here only. Today we studied how to draw the circumcenter for the acute angle triangle and obtuse angle triangle, and yesterday we seen how to draw the angle bisectors for an acute angle triangle. So today we will stop here only. Okay, and you just try to draw this, solve this practice set number 1. Okay, it is easy, you can draw it, solve it easily. Complete and send me on my personal number. So today we will stop here only. Okay, thank you and have a good day.